Good morning. My name is Segal. As I was introduced before, I founded a company called PureSec back in October 2016. And PureSec dealt with application security for serverless, and we recently got acquired by Palo Alto Networks. That's pretty much it. I was involved in application security since, I guess, the late 90s, dealing mostly with web application security when it was still new. So I was responsible and lucky enough to be responsible for research and development of some of the world's first products in this field, the AppShield, which was the world's first web application firewall, AppScan, if anyone knows IBM AppScan. So I was a part of the team that wrote that. Akamai Kona cloud security, WAF, client reputation products, and so forth. And as of recently, the PureSec serverless security platform, which was the world's first serverless security platform. These are some of the publications that I've done in the field of application security. HTTP2 fingerprinting, which I also presented a few years ago at conferences. And I think the most interesting one is the Apache remote code execution that I found back in 2002, which usually I say at this point that this gives out my age. Yeah. So other than that, I'm also the lead singer and guitarist for Israel's, I think, best noise band, Pits. And you can download their songs. I'll post the link later in Twitter. I love that glass. It's a cool trick. Keep doing that every 10 minutes and it'll keep people awake. Okay, so we'll talk about serverless security. I'll show you a few risks and pitfalls. I'll explain in a second. I'm not here to scare you. On the contrary, I'm trying to explain why you should actually adopt serverless because of security. And we'll get our hands dirty with a live demo that hopefully will work, and I'll send you off with a few action items. One thing to think about when we're talking about security in serverless, we have to explain what kind of security are we talking about. And because in a cloud, a public cloud scenario like serverless, the cloud provider is responsible for almost everything from the hardware, the locations, the availability zones, the database networks. All of that is handled by the cloud provider. The cloud provider is responsible for. You are only responsible for the application layer. So that includes your functions, your data, the IAM, as we will talk about, and obviously the storage. So you can see that the division here splits nice. However, what does it actually mean? And just like, this is the first time I'm trying this joke. Just like a double rainbow all the way. What does it actually mean, the shared responsibility model? And so if you look at the world before serverless, if, for example, you're using infrastructure as a service, and you look at this list of tasks, and you don't really need to read all of it. The fonts are small for a reason. But these are taken from all the PCI requirements for securing your application. You will see that the application owner is responsible for a large chunk of the duties, of the requirements, of the things that you have to fulfill. From monitoring everything, making sure that you have DDoS protection in place, segmenting the network, hardening the OS, etc. And when you adopt serverless, things become much better from your perspective. So the cloud provider is now responsible for a lot more. And you're only left with the application or securing the application layer, which obviously is a lot less than what it used to be. I'll quickly explain how serverless works. I pretty much hope that everybody knows this, but I need to use this chart in a second. So a developer deploys code to the repository, then deploys that as a function to the cloud, ties some event sources like an S3 bucket or I don't know, DynamoDB table. They will trigger a function. The function will do its job, hopefully generate some output. During the execution of the function, it will interact with other cloud services. And that's how pretty much things work. Now, how can an attacker even access your applications, your functions? And I have a lot of customers asking us, okay, so these functions are internal glue between cloud services. How can somebody even access those functions? So here are three or four main paths to manipulate the business logic. First is by injecting data into events. So each event has its own fields. If we're talking about an S3 bucket, that would be the name of the bucket, the name of the file. If we're talking about HTTP, which is easier to understand, we're talking about parameters, cookies, HTTP headers, all of which arrive as part of the event data and are accessible to the function. So those are easy ways to manipulate the business logic. We can run attacks like SQL injection, cross-site scripting, things you probably heard about. I hope so. Another path to manipulate the business logic is by deploying unauthorized code. So going not through the code repository, but somehow getting access to the cloud account and deploying new code. And I don't have to tell you about, phishing attacks and cross-site scripting attacks against developers. I'm sure you've all heard about it. Once I gain the credentials, and you will see a nice example of that in a second, I can therefore deploy my own code. Obviously, that's a very extreme example. Poisoning dependencies. So if your application or your functions rely on open source third-party libraries, if I know about that, and we've seen multiple cases in recent months of people poisoning open source packages, trying to inject, I think the most common scenario is Bitcoin mining code, etc. Then I can obviously manipulate the function. That's not specific for serverless, of course, but it is harder to detect when it happens in a serverless environment that you don't control. And last but not least, obviously tampering with the data. If a function gets invoked by an S3 bucket that changes, and if I can control that bucket, if it's left publicly open, again, an example that you will see in a second and you've all heard about in recent years, I can probably manipulate how the function is going to operate. And what can I gain as an attacker is pretty straightforward, just like the things I would gain in any kind of application layer attack, remote code execution, stealing data, bypassing authentication, leaking secrets, even denial of service. We'll talk about that in a second. I think last year and then again this year we published, we started with the top 10 lists, now it goes all the way up to 12. Another reference joke that nobody picked up. So the 12 most critical risks for serverless applications, this came out as a Cloud Security Alliance document together with PureSec. We're not going to go over the list, it's too tedious and there's a lot to talk about, but in the demos and in the live examples I will give in a second, we'll pick some of those and talk about them specifically. The need for protecting serverless applications, I think I made the point here, but if you look at traditional application security solutions like web application firewalls and runtime application self-protection, even network and host-based protections like IDS, IPS, they all require you to deploy something somewhere, either on a host or on the network. They need to be able to inspect network traffic or inspect the behavior of the host. And in serverless, by definition, as an application owner, you don't control not the network, in most cases, and not obviously the infrastructure. And so you need some other type of mechanism to help you protect serverless applications, obviously other than just doing secure development, which is a given. To put it into a diagram, if you today deploy an application and then you deploy some endpoint protection on the host to detect malicious behavior, IPS on the network, web security gateway to inspect outbound traffic from your application, and obviously next-gen firewall and the inbound network layer and a web application firewall, and you put all that on the infrastructure today, when you turn this application into a serverless application, into functions, these functions live in the cloud, or they're stored and they run in the cloud. And just like your users can trigger eventually those functions, so can attackers. So this is something you have to keep in mind. And without any type of runtime protection, your security for the functions boils down to how secure you wrote the code and how strict your configurations are. And we'll start seeing examples now about cases where this fails. And we'll start with IAM. I think this is the topic that everybody thinks about when we're talking about serverless security. Okay, so serverless functions should, in theory, abide to the least privilege concept, which means, and in this example, you can see a function that calls DynamoDB to put an item. In this case, I would need to grant the function that specific capability or permission, nothing else on top of that, right? The IAM model, and specifically the AWS IAM model, is extremely granular and extremely powerful. And just like with Spider-Man, you know, with great power, you need to be responsible for what kind of permissions you grant to the function. And by the way, this is something amazing that you couldn't really do in traditional applications. The ability to tell a part of your application that it can only write data into a very specific table is mind-boggling from a security perspective. This is, if you can harness this, you can make life really hard for an attacker. And you will see that in a second. In reality, developers, for many different reasons, either they're lazy, thanks for the cup, keep doing that. Either from being lazy, we're all lazy from time to time. I seen just like that all the time. Or because I don't know how to use the model, or because I'm trying to future-proof my application. If I know today that my function only needs to write data, but I know that I expect that in 2 weeks it will need to read data, I'll probably give it read-write together, or if I'm extra lazy that morning, I'll just give it a wild card. By the way, and first row, don't say anything, can anyone name and spell what is the right permission to grant the function if you need to use Dynamo put item? How's it called? Or most importantly, how do you spell it? Yeah, and how do you spell it? So camel casing, right? Yeah. So as you can see, AWS, sorry guys, didn't do it very easy for us to map between the permissions. Sometimes it maps one-to-one. Sometimes you have to read the documentation to figure out what you need. Another option is just to not grant the permission and see what kind of IAM error you're getting, and then deduce that. Debug prints all over, right? Now what happens? What happens when you do grant a wild card, for example, in Dynamo? Obviously, you end up with a colossal catastrophe. But everything here that you see on the list is now accessible to the function. And as long as the function is not being exploited, that's good and fine. But if an attacker manages to manipulate the function, then he or she can do all of these things that you see here. And we'll show that in the live example in a second. By the way, these are the most common issues we see with customers. That is exactly the reason why you keep hearing people talking about IAM, because it's hard to get it right, and not in a one function example like we have here. When you have dozens of functions and a lot of roles, it becomes more challenging to get it right. And as you will see again, I consider IAM to be like bulkheads in a submarine or in a ship. If there is a hole, if somebody manages to exploit a specific function, if I get IAM right, I can contain the damage, I can contain the blast radius to that specific function. And as you will see, that can be very frustrating for an attacker, which is obviously a good thing for you. And with that, we'll go to the first example. How many heard about Lambda Shell? Okay, so I think last year a friend of mine, Caleb, built this website to try to get people to hack a Lambda function. He actually created the worst case scenario for a Lambda function that allows you to run code on the machine. It's basically a shell, a web shell. Whatever you type is getting executed by the Lambda function. From an attacker perspective, this is the holy grail. This is the best case scenario, and obviously for you, that's the worst case scenario. In the old world of serverless applications, when you gain remote code execution or RCE, that's it. That's game over. That's the best thing you can hope for. And Caleb created that thing and offered a $1,000 bounty, which I still didn't receive. And challenge people to try to do some serious damage to his account. And when I saw this, I said, okay, this is very interesting for PureSec, for marketing perspective. That would be awesome if we can get to hack his account and publish that. That would be terrific. And so we started looking at what was going on. The first thing the first command I ran was env to get the environment variable of the Lambda that was running. And there's a lot of interesting environment variables you might want to look at, but there are 3 very specific variables that are super sensitive. And those are the session token, and there's a couple more, the secret key, the secret access key, and the you see them here. So what I've done was, and this is purely for fun and for ease of use, I took the 3 keys and I exported them, or I set them locally on this Mac. And then what I did was to call the AWS STS CLI to check whether I'm now assuming the identity of the function. So I should explain that using these 3 tokens, that's how the function basically authenticates itself. So once the function starts running, it goes to the STS service, if I'm not mistaken, gets those tokens and assumes the role for the execution period. And so getting access to those keys allowed me to basically run commands on the AWS CLI as if I was the Lambda role, for that matter. And lo and behold, that actually worked. Not very surprising, but I ran it locally, and then the first reaction was, yep, okay, I'm now officially running as the Lambda function. I can do whatever I want from my Mac, and pretty much game over, right? I can run commands. But then I started trying to run some of the commands from the AWS CLI, for example, listing functions, and then I got an access denied error. And then I tried a couple more to get the source code of the function and to list buckets, and I kept getting access denied, access denied, access denied. And then I thought to myself, okay, maybe Caleb is not as stupid as I thought. Maybe he applied the least privilege concept to the role that was running the function. And think about it, how depressing it is from an attacker's perspective to have remote code execution run with the privileges of the function and not being able to do anything. And it's not as if there is some command I can run that will tell me, here are the things that are open. I now have to iterate over all of the AWS CLI commands and see which ones I'm getting access to and which won't run. And so that was pretty depressing. Let me fix this. And then I thought to myself, okay, when there's a website, and there was a website here, usually people create a bucket for the website, for the static files. In this case, the website was lambdashell.com, so I said maybe there is a bucket, www.lambdashell.com, which is pretty common. And so I ran the AWS S3 API head bucket to see whether the bucket exists, and I got this empty line response. And I was thinking, okay, is an empty line means it exists, or is it missing? Did I hit something, or didn't I? And so I tried running on a different name, trying to head bucket on a different bucket with some made-up name, serverlesssecurity.presentation.com, and I got an error, like a 404 error, which now means that, okay, I know the name of the bucket. That's better. So the first thing I tried to do was to list the objects. This is like the parallel to an Apache directory listing where you can list the contents of a directory. I was basically listing the contents of the Lambda Shell.com bucket, and I saw that there are some CSS files, an index HTML file, nothing important that I could use. And so I said, okay, I can list the contents of the bucket, but maybe if I can write something into that bucket, that will be the proof to Caleb that I managed to hack into his application. And so for some bizarre reason, and don't ask me why, I can't explain, I decided that I will try to run delete object on one of the files that I saw there, and I will tell Caleb, hey, I managed to delete your file. The next thing I know is that I'm getting a call from Caleb, who was at the time at Black Hat in Vegas, and the site was down for 5 days. He couldn't get it to work. I deleted the most important file. Nobody could access the file. From my perspective, that was sort of game over. And also, none of our competitors could do anything to the site in the meantime. So I was very happy with that. So that was the Lambda Shell. Obviously, we won. We found a few other things, but that was the most important issue. And by the way, usually people ask whether they could just do the S3 trick without assuming the role. So the answer is no. The bucket was not publicly open. It was just accessible to the role of the Lambda function. So how do you get the IAM permissions right? First of all, adopt a role per function model. It's not always possible. It's very easy for me to stand here and say that, but if you can, make sure that each function has its own role. That will help you to achieve least privilege almost automatically. Always think twice before you use the asterisk. There are some services where you just can't do without that, but in most cases you can. If you're using SAM, you can use managed policies. Here's a bad example of using managed policies. I don't even know why somebody would create a policy like that. So full access to the database. A better one would be to use a CRUD policy, and if you're super smart, you can actually pick the specific permissions that you need, like put item that we've seen earlier. PureSec actually published an open source tool a couple of years ago that statically scans your code and will auto-generate an IAM role that is least privileged for you. You can download that. It's free. How much time do I have? So I can do another example. The next example deals with RDoS, or application denial of service through regular expressions, and third-party dependencies, which is something that a topic that I find very important. How many of you know Corey Quinn? Other than the first row, yeah? So Corey is a very colorful person. He owns a consultancy business for taking care of your bills, or making your AWS bills more efficient and reducing your costs, and has a mailing list, a very sarcastic mailing list, called Last Week in AWS. And I was talking to Corey and trying to prove why one would need a solution for application security for serverless. And Corey said, you know what? I have this application for registering users to my, my mailing list. If you can hack it, I'll help you generate some buzz. I believe the words were that people will see the spike on our website traffic from outer space, something like that. But he did mention that not a lot of logic sits inside those Lambda functions, so don't expect anything, spectacular. And again, that was very challenging, and we decided to try hacking his application. He was decent enough to give us access to the source code, which was hosted on GitHub. And while looking at the source code, we noticed that he was using SendGrid to send and receive emails. I'm pretty sure most of you know SendGrid. And inside SendGrid, there is a line here that you can see that parses the email address and turns it into an object. So it takes an email address, takes it into an object. It's actually using Python's own email package. And interesting enough, according to the RFC, this library actually supports long format emails where you have the name, the actual name of the person, and then the email in angle brackets. And that's based on the RFC. And so we started reading the RFC. That's always fun, especially when you're, dealing with parsers and there's going to be some edge cases that somebody screwed up. And so we decided to, after reviewing the code, of course, to try this very long email. We tried it with a few kilobytes, and then as we continued increasing the size of the email address, this very legitimate-looking email address, we started noticing that the function was, or the package actually, the email package was starting to slow down more and more, starting with microseconds, then milliseconds, and then as we, I think, hit 100 kilobytes of that, it was hanging for like 5 seconds, enough to for us to understand that we can get the Lambda function to basically stall and hit the timeout. And okay, so now you're thinking, okay, this is not serverless, I can do that on any application, but if you post it 1,000 times, then you basically choke the AWS Lambda service. So it's, you're hitting the concurrency limit, nothing is there to respond, and the site goes down, or that capability of the site goes down. Interesting enough, the site I think the service took a while to recuperate, a few minutes. So it was enough for me to actually take a movie. I didn't have to hold this thing going on. I just needed a Mac with a shell script to do that. And here's the error message that we got. And here's the thank you message we got from Corey. So that was the second example. And yeah, you could see the spike. I'm not sure how high up in space you need to be to still see it, but it was a nice gesture. Last but not least, I think last year I was looking around in GitHub and I saw that somebody wrote an HTTP multi-part foreign data parser for Lambda. If you guys don't know multi-part, then it allows you to send HTTP requests, and instead of concatenating name-value pairs inside the body or in the query string, you can actually send them in those kind of chunks, in those parts. And each part starts with a boundary that the browser usually auto-generates. And so you can put data of every parameter in a different chunk, and if you need to attach files, usually that's the mechanism that works. Now I noticed that this library was doing something very interesting. It was using a regular expression from the boundary to sort of parse the body of the request. And using someone else's input as your regular expression can be devastating and have a colossal outcome. In this case, what I've done was, instead of generating a boundary like randomly, I created a boundary that looks like a worst case, I think this is it, regular expression. And so when the package tried to parse the body, it basically started working really hard. Again, if you do that 1,000 times, the Lambda service will stop responding if that's your concurrency limit. Now we'll do the live demo. I just need 5 minutes for that. And pray to the demo gods that it will work. Actually, I need one more slide to explain the demo. So for the demo, we created an HR application for the HR team. This is actually an idea that came from our own HR, where people would send the CV as a PDF to an email. The AWS simple email service will grab that email, pass it as an SNS message to trigger a Lambda function. We needed that because we needed the attachment available. And then the Lambda function will extract the PDF file, turn it into plain text, run some candidate qualification analysis algorithms, and store the information inside DynamoDB, and in parallel send a receipt email back to the candidate that we got the email, we're looking into it, we'll contact them back. And that's how the system works, and now we'll play with it a little bit. So the fun thing about this is that we're just using Gmail for the example. And we'll start by sending an email to the HR team. Let's call ourselves John Smith. I'll zoom in when there are parts where you actually need to read the font. And then I have a PDF file here. And the PDF is just a regular fake CV, like a computer science CV. There's nothing, no malware in here. And we'll just attach it. And we'll write something. And we'll hit send. And now, and this is the fun part about serverless. I'm managing no infrastructure. I don't have to carry about. I don't have to care about email and storage and anything. Everything runs automatically now. There's one function, one database table. That's pretty much it. And you see, it's already back. We got the receipt email. Everything's working. They got our CV. I actually had a really nice UI front end for the HR team, but since we moved to Palo Alto, it sort of got lost in the process. So this is how you actually operate the application. Now, let's say for the sake of the story that I didn't get accepted to the job. Not sure why. Nobody would want me to work. But now I'm angry. I'm pissed. I want to get my revenge. And the revenge is going to be in the form of leaking their entire DynamoDB table back into the internet, or extorting them, whatever we want. And so how do we do that? And if this was a web-based application, the first thing I would have is a form where I can probably put some inputs into fields, and I would probably launch my favorite SQL injection tool or some other web scanning tool and start bombarding the form fields. In this case, I'm not as fortunate. I'm working with email, and it's not as if I'm expecting to knock down the Amazon Simple Email service. That's not likely to happen, and I won't comment on what happened earlier today, but I can't really do fuzzing on email fields. That's not likely to happen. So what can we do? So we'll try something else, whatever I'm typing here. I'll take the CV, I'll copy the file. Let me zoom in. Yes, and I'm going to change the file name a little bit. Now remember, unlike traditional SQL injection where if I send some characters, there's some chance that I will get an error message back with some stack trace information. It's not likely to happen in an email. I don't expect the developer to send back stack trace information in the receipt email, right? So I need some other way to gauge that the application is vulnerable somehow. So what I'll do is we'll try to do some kind of blind probing. Usually attackers call that time-based approach. So I'll put a semicolon, and then we'll type sleep. Oops, sorry. Okay, we'll put a semicolon, and then the sleep command, 5,000 seconds, and then a hash sign, okay? The trick here, and this is going to be the very legitimate attachment file name. The trick here is that if something is using the file name of the attachment inside a shell environment, which is likely because maybe the system is copying the file to some directory or opening the PDF with some command, then the semicolon is going to get it to execute the second command. So it's piggybacking on the original command. And then sleep 5,000 just because I want it to sleep for long enough that I will be able to sense that it's actually working. And then the hashtag is a trick that we usually do. So what happens now, and we don't have to wait the 5,000 seconds. You remember it took about 5 to 10 seconds for the previous experiment to work. Now it's not coming back. So I know that the file name is my location that's my entry point to the application. That's the part I can control. We talked about event data injection. So this is the part of the event data that I'm controlling that I can inject data into. So now we can install the Lambda function. That's not a lot of fun, but it is a signal for us. And so we'll do the next thing. And the next thing is to get the source code of the function. And how do we do that? So I already created, let me show you. So we are going to use this payload. This is the file name. And what it does is basically the same semicolon. Let me increase the size. The same semicolon trick, and then instead of sleep, I'm defining, or I'm calling curl to silently fetch data from pastebin, and then pipe it in to a Python child process. What's inside that pastebin URL? This is the code. It's very simple. How many? 0? Okay. So all the code does, extract the name of the function of the handler, and then extract the source code, basically cat it, and paste it back to me over a return email. And all I need to do now is attach the file. Again, this is the file. And we'll hit send. I'm almost done. Within 10 seconds, what's going on now inside Lambda, my code is running, fetching, using curl, the data from pastebin, running it, extracting the source code of the function, packaging it inside an email, and sending it back to me. And there you go. So two things happened. The function exited normally, so I got the receipt email, which is very cool, and I got the source code of the function. Now, keep in mind that if you're looking inside in CloudWatch or CloudTrail, there was no violation done here. I'm allowed to get the source code, and I'm allowed to fetch data from the internet, and everything was allowed here, so you're not going to see any hints that somebody just leaked the source code. I'll already have the source code here with color coding for you. Let's quickly go over this. So this is the handler. We see that the developer is using Dynamo. They're getting from the SNS message the actual payload, checking that it ends with a .pdf, which is terrific for security. So you're whitelisting the extension, which is, by the way, why I kept finishing my file name with a hashtag PDF. And then basically this is where the bad things start to happen. So the developer is using a very common open source utility called PDF2Text, which does exactly that, but embedding my file name directly without doing any kind of sanitization into the command. So when we did semicolon sleep, basically both commands ran. Okay, that's pretty easy to understand. And then putting in the item, taking all the data, putting it into the DynamoDB table, which is now the table that we want to get access to. So how do we do that? Very similar. I created another Python script, put it on pastebin. All it does is create its own DynamoDB client and run dynamo.scan. And Angela would tell you that that's not good for a performance perspective, but we don't care. And I don't even know the table name. I'm reusing the same environment variable defined by the developer, by the way, who made the right choice of not storing not hard coding, but using an environment variable. There are better ways to do that more secure, but that's for another presentation. So all we need to do now is send another email. This time I'm going to be a bit more cynical. Something like that. And then very similar payload, curl, fetch the data from pastebin, and then execute it. And if the demo gods will give me 20 more seconds, or you, we will see the data coming back. And that was a full exfiltration of an entire database table in 3 emails. Usually if this was like a traditional application with a database and I was doing SQL injection to get the data, that would take me thousands of HTTP requests, which is very noisy. So as an attacker, this was a terrific hack. So you see, this is the full dump of the database. This is where you say, oh, okay. But keep in mind that this is not a vulnerability in the framework or in the platform, in the underlying infrastructure. This was all the developers doing. 2 severe violations. 1, using user input directly and allowing the event data injection. And 2, allowing the function to do more than it actually needed. So the function only needs to put item. Imagine what would happen if the developer would have changed the permissions of this function instead of doing Dynamo wildcard, just put item. The only thing I could do as an attacker was put items into the table, which is pretty frustrating and not very interesting, I guess. So that was this demo, and I'll finish it off. Just take a picture of this. I mentioned the top 12 document. Make sure you download it. And there is I think, a very fun project that I created and published called the OWASP Serverless Goat. It's a serverless application. You can deploy it from the serverless application repo. It's just a click of a button. It has all the fun things you've seen here. You can play with. It has a manual, a tutorial that explains how you hack the system and how you secure it. And after a few hours, you can already show off your serverless hacking techniques to your colleagues. And Function Shield, which is a free library that will help you to secure your functions, and obviously the IAM list privilege tool that I mentioned earlier, that's all free for you to use. That's it. Thank you.